I'm Fergus Sinclair, Chief Scientist at C4ICRAF, the Centre for International Forest Research, World Agroforestry, and co-convener of the Transformative Partnership Platform on agroecology. And I'm delighted to welcome you to this online session of World Water Week on the very urgent issue of incorporating inclusive water management and aquatic food in agroecological transitions. And together with the TPP and C4ICRAF, the session was organized by the Agroecology Coalition, IMI, the International Water Management Institute, World Fish, and YPARD, Young Professionals for Agricultural Development. And you'll hear from people from these various institutions as we go ahead. We're also very pleased that this is a gold standard session, with women taking 4 out of the 6 lead presenter slots, and 3 out of 6 presenters we can consider to be young, although all of us may be young at heart. And one presentation specifically articulating a youth perspective. So without further, before we go, let me just say a few key things about how the session will run. If you want to ask questions, you need to put them in the chat. Most people won't have be able to unmute themselves. So if you are wanting to ask a question, please put it in the chat. There are going to be 2 audience polls, and for that you need to log on to Slido. And Fabio, do you want to just give people the details of how they do that? The first poll will be in about 20 minutes time, but you might want to get prepared for it. And I guess, Fabio, you will put this slide back up again when we get to the polls. But for those of you who've got a chance now to just click on that QR code, then you will be able to take part in the session.
Yep. So scan the QR code with a mobile device, or go to slido.com and enter the code WWWAE, as in World Water Week Agroecology. And then when the polling will be active, you will see it happen. Okay.
Okay, wonderful. So without further ado, let's kick this session off with a framing presentation on our topic that Sarah Freed from World Fish is going to start. Sarah.
Thank you, Fergus, and hello everyone. Thanks for joining today. So yes, we'll start by framing this session today on inclusive water management and aquatic foods in agroecological transitions. So welcome, and I'm just going to start with a little outline. So to start, we'll just get our feet wet on what the challenge is being presented here and how water, aquatic foods, and agroecological transitions can confront this challenge. Then we will wade in a bit to details and look at how water and aquatic foods relate to the 13 agroecological principles. And finally, it will be time to either sink or swim, getting into the bigger topics on how water and aquatic foods can relate in food system transformation and resilience to climate change. So just to start with this challenge, we know that globally, hunger and food insecurity are rising, and also especially in Africa. We know that there's several key drivers, including conflict, climate change, environmental degradation, biodiversity loss, and persistent inequality. And looking at these last 4, we also know that these are very relevant in food systems. And we know that food systems are both major contributors to and undermined by each of these drivers. And so we want to look in a little more detail here, in particular, how these 4 drivers are contributed to in agriculture. So very recently, there's been study on the greenhouse gas production of agriculture, and in 2019 it was up to 22% of global greenhouse gas production. Then looking at environmental degradation, there's several ways agriculture contributes, and so just a few I'm naming here. One is 70% of human freshwater utilization is done for agriculture. And then prevalent increase of agrochemical use and soil erosion is happening through agriculture. We also have seen that agriculture is actually the largest cause of biodiversity loss by sector, and it contributes in several ways to persistent inequality, for example, through land grabbing, through monopolies on seed patents, and persistent gender biases in land ownership and access to finance. So let's go on to why are water and aquatic foods fundamental for food systems. First of all, water is foundational to food provision. Then water scarcity is also an increasing global challenge, and it's a key constraint to agricultural production in many places. In addition, over-abstraction of water depletes natural water bodies and undermines numerous ecosystem services. Finally, flood and drought, which are exacerbated by climate change, can contribute to food insecurity worldwide. So on the side of aquatic foods, the provision of protein is very important, and 3.3 billion people rely on aquatic foods as their primary animal protein. We also see that aquatic foods are nutrient dense and can fill micronutrient gaps, especially in vulnerable populations. And the demand for aquatic foods will continue to grow globally to 2050. Despite all of this, water and aquatic foods are rarely addressed in agroecological transitions. But this is something we are hoping to address today. So let's look a little more at what we mean by agroecological transition. So in this type of pathway, the aim is to simultaneously address global challenges of hunger and food insecurity, as well as the drivers, the ones I mentioned earlier of persistent inequality, environmental degradation, biodiversity loss, and climate change. And so an agroecological transition can shift current agricultural and food systems to more sustainable pathways. And it does so by taking a holistic approach based on an application of universal principles to deliver resilience, resource use efficiency, and social equity and responsibility. So let's look a little more closely at these agroecological principles that are applied through agroecological transitions. Here I'm presenting a set of 13 principles that were developed in 2019 by a high-level panel of experts. These principles are explicit, normative, and causative statements. They can guide decisions and actions, and they also incorporate the 10 FAO elements on agroecology. There's many ways to kind of classify these principles, but one that's useful for us today is to see the principles that are relevant for the food system, and then those that are most relevant for the agroecosystem. But you'll also see there's many interconnections and relationships among the principles as well. So these principles have proved useful in delineating agroecology across contexts, and they're also under active development, as you'll see in this session. So when we started to look more closely at how water and aquatic foods are currently represented in agroecology, we saw that there are many gaps. And so this is an example based on the agroecology research literature. We looked at studies published between 1990 and now, so over the past 32 years. We see that the agroecology-based literature is growing exponentially, but the representation of water and aquatic foods in that literature remains very small. So over those 32 years, only 1.8% of that published literature has water as a focus, and then less than 1% has fish and aquatic food as a focus. And we also saw that this overlooking of water and aquatic foods that is happening in agroecology research is also corresponding with similar gaps that are happening for agroecological strategizing, planning, and decision-making. So how might we address this? We're starting basically with making water and aquatic foods more explicit within those 13 principles. And so I'll show you what we are proposing for that. We look especially at 5 of the principles, and so I'll go through one by one. The first one is for co-creation of knowledge, which initially mentions farmers, but we suggest that it's important for all producers in terms of exchange and co-creating knowledge. So to include beyond the farm participants. Then looking at the element of recycling, we propose that recycling and efficient use of water is as important as efficient use of biomass and nutrients. For the principle of soil health, we propose to add water quality. And this is because, like soil health, water quality is foundational for agroecosystem functioning and for hygiene, as well as support of aquatic and marine life. Then we look at the principle of biodiversity, and we suggest that it needs to explicitly encompass the impacts of agriculture on aquatic and marine ecosystems, as well as on terrestrial environments. And then finally, we looked at economic diversification. And once again, we see that it's important for all food producers, not just for farmers, and to look at producers and food actors across scales of production and across the value chain, including beyond farms. So these are the 5 principles we suggest to more explicitly include water and aquatic foods. And now my co-host Matthew will go into a bit more detail with these. Thank you.
Great, thank you very much, Sarah. And if you could change the slide, please, thank you. So as Sarah's indicated, too much and too little water are major constraints for food producers in many places around the world. And they're a key driver of food insecurity and economic hardship. And we think it's an imperative that if agroecology does what it says it wants to do, which is change food systems, then there's got to be recognition of the importance of water in agroecological systems, and not only water, but also other, fisheries and other food production systems within that context as well. So as she said, we're thinking about how the 13 principles can better reflect this, and have suggested some changes to the principles, which are highlighted here in blue. I'm not going to read them out, but I'll just go through briefly. So we think that, and it's key in agroecology, a key focus must be around using water efficiently and effectively as possible, and recycling where that's possible and where necessary. For example, through reusing drainage water to the extent possible, and introducing technology such as drip irrigation, and things like mulching to reduce water use. Secondly, we need to think about how we protect water sources and reduce sediment and pollution inputs, including, of course, from organic fertilizers and pesticides. So we know that agroecology promotes this idea of minimizing certainly the use of agrochemicals, and promotes more organic inputs. but those can also pollute water, and we've got to be careful with water sources. We need to have buffer zones around water sources, and we need to keep livestock, etc., out of rivers. And one point that we really do need to emphasize, I think, is thinking at a more of a landscape scale. It's obviously necessary to protect downstream water quality. So for farmers and others to protect downstream water quality, to ensure that downstream ecosystems aren't adversely affected by farming practices, which of course at the moment we know they certainly are, and agroecology needs to improve on this. Next slide, please. Sarah, next slide, please. Thanks. We also, on the 13th, on the principle on biodiversity, we want to extend this to ensure that it includes all sorts of ecosystems, of course, not just the farm ecosystem, but also up to the landscape scales. And very importantly, it's got to encompass as well aquatic and marine environments. And this is, of course, is a recognition of the need to protect biodiversity across all different scales, from field to landscape, which I think is already in there. But it's very important to ensure that activities undertaken at the farm level don't have deleterious impacts on downstream ecosystems. And we know that ultimately these rivers flow into the sea, and that, for example, near-shore marine fisheries are very dependent on the nutrients and so on, which are carried into the sea. Ecology needs to bear this in mind and make sure that it's thinking at that landscape scale and including into the marine environment. And also this is very important because of the many hydrological processes drive a lot of the ecosystem functions which are mentioned here. I'm talking about the functionality of systems, and it's the hydrological processes which drive and underpin those functions, and therefore we need to maintain those functions in order to maintain many ecosystem services which benefit communities within river basins. Next slide, please. Then there's two other principles, one on economic diversification, recognizing again that, as Sarah said, not all food is produced by farmers, and that we need to incorporate other food production systems, including very importantly fisheries and food systems coming from aquatic systems, but also non-timber forest products, etc. And these should be explicitly recognized within the agroecological community. And of course, co-creation and sharing of knowledge should also recognize this, and that it's not just farmers that we're targeting, but if we want to change food systems, then we've got to incorporate these other food producers as well. Next slide, please. And so, yeah, this is what Gleisman produced in 2007 as a roadmap for change. So as I said, agroecology is a way of redesigning food systems. The first 3 steps of this transformation relate specifically to farmers and what they can do on their farms to convert to agroecology, whereas the additional steps 4 and 5 go beyond the farm to the broader food system and societies in which they are embedded. So we think that we broadly need to think not just about farms and farmers, but all food producers. We need to be taking into account the water and the aquatic food, and how these link, how the producers of these foods link to consumers through business models, novel financing mechanisms, etc. If we want to change food systems, then we have to bring this in. And it's also very important that, as we said here, we think about the landscape as a whole, so going much beyond the farm. We've called it ridge to reef here, so thinking about all of the systems within a landscape and how they link to agroecological farms and farming systems, and importantly to think not just about fresh water but also marine and brackish water and so on within catchments and basins. So by thinking about this in this more holistic framing, we think agroecology will be more impactful. Our final slide, please. And so just a few points to finalise on. One is that we need to reevaluate the role of irrigation and agroecological approaches. Very little is discussed in relation to irrigation in agroecology, and yet at the moment 40% of crop production in the world, 40% of food is produced from irrigation on 20% of land, and irrigation is likely to become much more important in the future with climate change. So this is a key area that agroecology needs to address, and it needs to be clear about what is the role of irrigation within agroecology, and how can irrigation systems be transformed to be much more agroecological. We need to think about, we need to broaden the scope for a broader water management solution. So not just in irrigation, but in other ways, thinking about soil and water conservation, rainwater harvesting, etc. And finally, we need to consider adaptations for water availability, management, quality, and connectivity, and particularly at that landscape level, thinking about how we connect through the basin from, as I said, from the highlands down to the sea. Thank you very much.
Thank you, Matthew. That's excellent. And these presentations will be made available to you. So all of these resources and so on that are on the slides, you will be able to get access to. And the TPP platform will have all of that information on it after the event. Now, Fabio, perhaps you can get the Slido information back up. Because this is the moment when everybody in the room needs to take part in answering 3 questions. So we've just heard this initial framing for the session, and we wanted just to get a little bit of a opinion from you. The first question is, and you're being asked whether you, the extent to which you agree or disagree with the statement, agroecology is as much about water as it is about land. And you can either completely disagree with that, you can be in full agree with it, or you could be neutral in the middle, as somebody is, or some people are. So please get your rating in. As this session is in World Water Week, we might expect that we will get quite a lot of people who've joined the session agreeing with this statement. And that certainly seems to be the way things are looking at the moment. But there's still many of you who need to vote. So we can't leave it running for too long, because of the tight timing on the session. And I presume, Fabio, once we close it, people can't vote after that. Is that right?
Yeah. So once we move to the next one, the polling is closed. But I think there's a pretty strong consensus on this one. So we might want to move to the next one.
Okay, so let's move to the second question. And the second question is, again, for you to agree or disagree with, being inclusive of water in agroecological principles makes them less appealing for some, for example, by no longer referring to farmers. So is revision of these principles making things more complicated, less tractable? Are we creating problems for ourselves? So we're beginning to get people voting. So getting a little bit more of a spread on this one, but also a consensus around tending to disagree a little or a lot, but not entirely.
Yeah, we have a few who
we've got
just voted on the other side.
We've got some farmers in the audience. Okay, fantastic. And let's go then to the third question, Fabian. And this is suggesting there should be separate sets of principles for land and for water to ensure each domain is fully covered. Do you agree or disagree? And read the question carefully. Do we want integrated principles or separate principles? And as you can see, these questions have been carefully constructed so that there isn't an affirmation bias. Super. We're still getting a few votes coming in.
But I'm going to leave this open so they can still
Okay.
vote. Okay.
Excellent. So people can continue to vote, but we will move on. Thanks very much for taking part in that. It does indicate that there is some variability, particularly in that last question. And let's see whether we can address that to some extent in the next set of presentations. So let me move quickly to invite Jenna Tesdal from YPARD to give a youth perspective on aquatic food and agroecology from the Democratic Republic of Congo. Jenna.
Super. Thank you so much, Fergus. Can someone just quickly confirm if you can successfully see my screen share?
Yes, we can.
Yes.
Super, fantastic. So it's a huge pleasure to be here. As Fergus introduced me, my name is Jenna Tesdal, and I have the huge pleasure of serving as the director of the Youth Network Young Professionals for Agricultural Development. And for those of you who don't know us yet, we are an international youth network in over 70 countries, and we are a members-based organization. And it's really for young people under the age of 35, serving along anywhere in the agricultural value chain or food systems value chains. So this is a network to help people develop their capacities, but also do policy advocacy. And we have some really interesting projects in the countries, and one of them is on aquatic food in DRC. And that's what I'd like to tell you a little bit more about today on behalf of my colleagues who have shared information about their project. And I think there's a really unique opportunity right now, and that is really ongoing interest in youth and international dialogue. And this connects closely to agroecology, and especially the transformative aspects of the transformation level that we are striving for food systems transformation, because we're talking about community in food systems. We're talking about society. And of course, we know that young people are a huge and very important component of food systems and the future and the present leadership, of course, as well, of food systems transformation. And so that's what I really wanted to emphasize, is this aspect of participation in food systems, which is one of the aspects that's really challenging to reach and often under-addressed in agroecology transitions thus far. And so I think this project is a really exciting example. The Community Solutions Project that I want to tell you about is a cooperation between our members and YPARD DRC with IITA and FARA as well, so the Forum for Agricultural Research in Africa. And they dreamed up this project together because they saw community interest in locally produced fish. And this was actually the preferred food for local people when they would consume fish, but there were many imports. And so the young folks said, okay, we see not only an opportunity to produce food for ourselves, to increase our food sovereignty, but also to have an entrepreneurial experience, to gain some income and food for ourselves. So the team there worked with IITA to install 5 ponds in the territory of Loangu. And for those of you who don't know where that is in the eastern part of DRC. And the eastern part of DRC and the southeastern part have a natural landscape which is rich in wetlands. And so this is a perfect opportunity to work together with the natural landscape to produce food to gain a livelihood, to gain an income without doing what maybe was done in my homeland of Iowa in the United States and drain the wetlands for other agricultural production. So now they're producing 10,000 tilapia fish every 6 months, so about 5,000 kilos every 6 months, and they're able to consume that themselves, but also have enough to sell to the local market as well. So this is aiming to reduce food imports and also increase their income. So this is a great example of social values in food transitions, of course, of animal health, because they're not using antibiotics or anything like this to produce their fish. They're really using the natural wetland. They are engaging in community participation because young people from the community participate in YPARD, but also communicating then with IITA, with FARA, with YPARD at a regional and global level. And that's contributing to this idea of co-creation of knowledge and knowledge sharing. And in the end, then we have a really great food systems transition example project featuring participation. So just one last picture so that you can imagine what this floating cage agriculture looks like. These are photo credits to the leader of the project, Eric Dunda in YPARD DRC. And I thank you so much for listening to this example of agroecology in aquaculture production, and encourage you to reach out if you would like to work with our team there more. Thank you.
Thank you, Jenna. Excellent example, and great to be getting the aquatic food into the discussion. Let's move straight on to Cambodia, where we want to look at some of the problems that too much water can create and how that can be addressed. So let me invite Rada Kong of CIRAD in association with CASIC to present. Rada, please. We can't hear you. Are you unmuted?
Can you hear me and see me now?
Yes, I can hear you. Yes, and see you. Super.
Very good. Again, thank you very much for the introduction. Good morning, good afternoon, everyone. My name is Rada Kungs. On behalf of Dr. Sarut, I would like to express our appreciation for the opportunity to share with all of you about how we deal with the too much waters in Cambodia from the agroecological perspective. As we know, Cambodia is one of the most vulnerable country in the region to the natural disasters from the impact of the climate change. And based on the data of the World Bank published in the last 4 decades, actually flooding is the most occurrence, accounting for 46%. And for example, last year, we got a lot of rain just 1 week, the first week of October, and there's a flood in Cambodia. There's two flood actually. There's a what we call it the flood from the rivers, as we have the Mekong River, and also the flood from the flash flood from the rainfall. And last year in October, we got this flash flood just 1 week. And like 14 provinces affected by this flash flood. And based on the Mekong River committees, there are several factors of the floods from the climate change, infrastructure developments, dam construction, and importantly from the change of the land use and the land covers, mainly from clearing the forest to for the farmings. And for managing the flood and solving the problems in Cambodia, we have the National Committee for the Disaster Management that have all the ministry as members and have the structure from the national to the province to the district and to the commune. But then as far as we concern about how agroecology can contribute to deal with the too much waters. We for us the diversification, biodiversity, and soil health is the foundation of the agroecology principle in order for us to store the water, to retain the water as much as possible on the site, on the place. Our intervention focus on 4.4 intervention. We promote the diversification of the farming system and also a diversified landscape. We promote the growing of the perennial species along the stream, along the canal and the rice field bands. We also promote the integration of the crop and livestock and tree. And lastly, we try to integrate in the cropping system the species or the variety that are more tolerant to the waterlogging. All of that is just mainly to retain the water as much as possible on the site, to reuse the runoffs, the soil erosion, reuse the sediments, and also improve the water qualities. And here are some of the example on the I put in the photo. Here's the silvopasture that we introduce to the farmers, that they can maintain, keep the tree, and then we establish the pasture land under the tree. And here you can see here's the rice bunds, but then we plant the mulattoes to protect the rice bunds, and also to use it as a for the animals. And on the right, you can see here is a very poor degraded cashew plantation, and we intercrop with the stylo for seed and also for fodder. The stylo can also use to improve the fallow lands in order, and also for the restoring the reforestation also, that we can use the stylo. And some other crop also, because here in Cambodia, when we talk about the agroecology, it's mainly about the conservation agriculture, that we have the research for development programs in 2004. We apply for all the two main agroecosystem in the lowland and also in the uplands. For the upland crop, we have this soybean on the sorghum residue, as you can see the photo. The next one is the maize we do a green sowing of maize on the sunham, on the standing sunham. Here is the rice, no-till rice on the Stylosanthes guineensis, and stylo residue. And below you can see here in the fruit tree plantation.
Radha, you need to come to a close.
Yes, and also in the rubber. And just to the last slide for you, that at the end, what we want is to increase the soil organic carbon. One, we can optimistically say that we can increase the soil carbon more than 500 kilo per hectare per year. And we see from our assessment that agroecology, the management on the field, can increase the water infiltration 2 times, meaning that we can reduce the soil loss and improve the water qualities. Yes, that's all for my presentations. Thank you very much.
Thank you, Radha. Superb examples there of what's happening in Cambodia. Let us now shift from problem of too much water to too little water. And I'd like to ask Dr. Lafdal from Mauritania to give us his insights on increasing severity and frequency of drought. Can you unmute yourself, Dr. Lafdal? We seem to be having a...
Oh, he logged out and he logged back in. Can I ask the support to please make them again co-host? Otherwise, he will not be able to speak or present. I hadn't noticed that he had logged out.
While we're doing that, let's go on to the next one, and then we'll come back to Dr. Lafdal once he's been given the co-host status. So let's move to India, to Andhra Pradesh, and how agroecological practices perform best in drier conditions and what the implications of that are for scaling. So Swati, can you
Yes.
deliver?
Yes, certainly. Thank you so much, Fergus, sir. And I hope my screen is visible. Namaste, everyone. My name is Swati. I am working as an associate scientist with Severity and deployed to the natural farming program in Andhra Pradesh. So what we are basically in the next 5 minutes going to see that how agroecological practices are not only just solving the problems of water in arid regions of Andhra Pradesh, but is also how it is being carried out by the women self-help groups and their institutions. So just for developing a context in the next half minute, so it's the Andhra Pradesh Community Managed Natural Farming Program is basically a initiative of government of Andhra Pradesh. So we have seen previously the presentations are talking about going beyond farms and then landscapes and then community and then society. So we are talking about a good state. It's a sub-regional landscape that we are looking at in the state of Andhra Pradesh, and what we are looking at is. Just want to understand what is natural farming. We are looking at natural farming as a holistic land management practices in the program, and we want to leverage the power of photosynthesis and natural farming and its subsidiaries actually fall under the larger umbrella of agroecology. One of the most non-negotiable, which we in Andhra Pradesh want to look at, is that we don't want to use synthetic fertilizer, pesticide, herbicide, weedicide. Anything which is external to the farm is something we want to shun, eventually in an iterative and a phased manner. So these principles are basically based on the learning from the last 6-7 years that the program has been implementing, and it bases itself on the 2 decades of work on social mobilization and capacity building of communities that has happened, which I will come later. Now, one of the big I'm sure even the people in the room really talk about this. Where is the evidence? Does this work? Why is it a state government? Why we want to talk about universalization of these? So to bring that rigor of science, the program and to remove this, this anecdotalism and mythical aspects, we have liaising with national and international reputed institutions across the globe, that they come and do research with us to ensure that the scientific rigor is not compromised. And I'm presenting here one of the work of University of Reading, and this is one of the first studies and a very powerful study which has been done over 2 to 3 years of time, and it has been ensuring that some really key questions on natural farming is addressed, and one key question, especially for drier areas in India, especially and in the context of Andhra Pradesh, is addressed. We are looking at so the study was basically conducted after a very detailed stakeholder consultations where 3 hypotheses were generated. First question was on yield, second was on water and soil, and third question was on earthworm. So and we didn't want to just look at natural farming and conventional farming, right? It would be good to ensure that natural farming, then there is something called organic farming, which the definitions are there on the screen, and then there is conventional farming systems. And what we did was that we identified 6 districts. So there are 30.
You need to speed up, Swati. You need to speed up. You've got several
so
slides.
So in this, the findings basically showed that natural farming systems have been superior in the terms of yield, along with the biodiversity, especially with respect to earthworm. This is a crucial slide that I would just like to focus on. That it was observed that natural farming has significantly higher soil moisture content as well as lower soil temperature as compared to both the other treatments of organic and conventional systems. Now, this brings into focus that one of the third questions, that we did not look at water independently of soil. So land and water goes hand in hand. And we also realized that there was a negative correlation between the sites when the treatment started before it. And this led us to find that natural farming works more effectively in drier regions, especially Andhra Pradesh is divided into 3 agroecological zones. So if you can see on the screen, the green diamond is basically natural farming, and the blue dots are conventional, and the orange squares are organic. So if you see that the soil moisture content in all the is more in the natural farming systems as compared to other systems, and the soil temperature was much lower. Yes, and this was attributed to the mulching, which was only done in the mulching, which is an intercropping, which is an integral part of the natural farming systems. Now, this is just of the 6 districts. Is if you can see the Anandpur and Kadapa, these 2 regions are landlocked; they are arid regions, and you can see that the triangle, green triangle, is above. That means that the soil retention capacity, soil moisture content has been high. Now, how did this happen? I'm going to close my wording by this, that we went beyond the physico chemical component and we integrated with social and human elements. And that is where the women self-help groups, the farmers who are part of this women self-help groups, and women played a major role to bring about this change and impact. And this knowledge transfer, this is very crucial to the agroecological transformation, to look at it from water and soil perspective. Thank you so much. Yeah.
Thank you, Swati, and thank you for getting such a lot of information in a very short presentation. Now, let us see whether Dr. Lafdal is now able to put on his microphone and speak to us.
Thank you very much. Really, could you hear me?
Yes, very well. Thank you.
Yes.
Thank you very much, and my apology for the problems with the internet. So I will try to share with you our experience in Mauritania regarding how we are dealing with those issues, really in the context of climate change and the context of aridity and water shortage. As you know, Mauritania is really an illustration of the Sahel, and we are really really facing continuously more and more really problems, especially in the hyper dry lands in the northern part of the country. Those parts in the north are more really affected by the drought and water shortage due to climate change than the southern parts that are situated in the Senegal River. In this present
I think he has internet issues.
Let's just give a few seconds to see if he comes back. If not, we'll move on and maybe see whether we can pull him back at the end. And otherwise, we'll make his comments available in writing afterwards. Okay, let's move to present the Gunawardena, who's going to tell us about interesting developments in Sri Lanka around redirecting. We'd lost you, Mohammed. We're going to move on to the next presentation and then come back at the end. So, Prasanthi, please.
Yeah, thank you very much. So I'm going to talk about Sri Lankan case study that especially focusing on the payment for ecosystem services. So when you look at the water suppliers and the users in a broader watershed and the downstream context, we can recognize the people who are in the upper watersheds are basically the government owned, and then the forest department and the privately owned lands. But downstream you can see a variety of stakeholders who are using the water both as a source, that is the for the electricity generation and the water consumption and the irrigation and the agriculture. But there are industries who will be using water as a sink for to discharge their effluents. So let us look at from an economic point of view, what is the best thing for each of these groups to do. So I'm going to present a case that the best thing for all of them to carry out the water and the soil conservation measures in the upper watershed, focusing on this agroforestry kind of concepts. So when you look at the power generation, it is always cheaper for everybody to generate hydropower rather than importing coal and oil from the outside the country. And because you will be saving on the most needed foreign exchange, plus you will be avoiding the air pollution from the thermal generation. This is a small case study that we have carried out in the Rantabe Reservoir in Sri Lanka, that you can see from the current landscape. When we look at the improved scenario, the savings, the total cost of these two options will be reduced, and plus there will be, from the reservoir point of view, there will be additional dredging if you do not do the proper conservation in the upper watershed, and then this reservoir filling will result in the reduced hydropower capacity, and then the loss of electricity, plus the thermal generation and the air pollution and so on. So this table shows you clearly from the current land use, from the improved scenarios, that how much saving can you receive from the annual basis. And then also we can think about what need to be done, looking at this context, that there are cost and benefits that are very clear to two parties. We can arrange payment for land owners to implement their soil and water conservation, and there are benefits to the electricity board because they are saving on the dredging and the thermal power, and the mini hydropower plants also can get their water throughout the year, and then also there will be avoided thermal power generation. Plus there will be payments or the benefits to the global community, because we are avoiding carbon emitted to the atmosphere, the avoided social cost of carbon, it's a big number, like per ton it is now almost $84. So also water board, water supply board can invest in the soil and water conservation measures, because having more water in the downstream will avoid the cost of the sediment will be reduced, water will be better in quality, so the water treatment cost will be reduced. In the low-lying areas in Sri Lanka near the Colombo city, now we can see the increasing levels of salinity. So when you have more water, this burden of salinity and having salinity barriers and so on all will be reduced. So therefore there is a justification, economic point of view, to arrange payments among the water board and the farmers. Plus, there will be downstream industries who benefit from the large volume of water, because they need this dilution. So, I mean, if the water is not there, they may have to go for a very strict water treatment or the higher cost. So, therefore, more water is beneficial for them. So, the payment need to be arranged among the farmers and the industry. So, we have discussed three cases that, how this is economically justified. Plus, the farmers will benefit definitely, and overall the country, because through these agroforestry interventions, there will be additional income, because you are cultivating multiple crops. There will be reduced levels of artificial fertilizers, because you will be growing nitrogen fixing trees in the land, and there will be chemical application will be reduced, because it is an integrated system. The attack of the pathogens will be avoided, and the health benefit for the nation, because we are avoiding chemical applications, and the global benefits from the carbon fixing. So, I mean, in this way, we are, establishing our case that why it is economically justified that this upper watershed areas, we should be doing the soil and water conservation, and a clear case of payment for ecosystem services. Thank you very much.
And thank you for that very clear articulation of practical ways of using the value from the water to protect the watershed. Now, Dr. Lafdal, if you're now able to speak, just 2 minutes, because we're almost at the end of the program, and we will perhaps make your contribution available in writing to everybody as well, if you can supply it to us. But Dr. Lafdal, are you?
Yes, please. And really, my apologies for my problems today with the internet. I will quickly share with you our practices and what we are really doing in the context of adapting the Wasian context, the Wasian ecosystem in Mauritania. As said, this is a part of the livelihoods, and it is inside the context of climate change adaptation, in a context of very huge, very hostile conditions in terms of meteorological and in terms of water availability. So, as you know, in Mauritania, and especially the hyper dry lands in the northern part of the country, are severely affected by the consequences of climate change. In those areas, fortunately, we have the Wasian ecosystems that are originally not very, very dependent on the water resources regularity in terms of rain. So in those areas, the communities try really to bring the new scheme that is in line with the context of and the needs and the requirements of the climate change adaptation. And till now, this really gives a very, very satisfactory results in terms of production, and really bring more experiences from the other countries and other regions of Mauritania. I can just highlight the importance of really how to align the Wasian production in terms of dates with the different cultivars, with the crops, including new species that are really brought from the southern area of the countries. So in the oasis of Mauritania, the agriculture is practiced really in a manner that is more and more really compliant with the climate change adaptation requirements. So the recommendations or the topics that we are working on to really sustain the results in those areas are mainly linked to the putting the climate smart irrigation at the core of the agriculture practice, and the creation of a national gene bank for the conservation of our resources, our local resources, and of course shifting more and more to the exploitation in with organic fertilizers, and of course putting the local knowledge and the local experiences at the core of the practice of the field practice, with of course some priority to the local products in accessing the markets, and of course a kind of support and continuous.
Dr. Lafdal, that's a great point to finish on, the importance of the local knowledge and markets. Excellent, and thank you so much, and apologies for the technical issues. We now need to close. Let's at least have one question from the poll, the final poll. Fabio, if you can put up the Slido again. Hopefully people are still connected and able to vote quickly.
These are the results of the last one, so I'm going to move.
Let's move to the next one.
Yep.
So the question is, the statement is, combining land and water is fundamental to achieving agroecological transformation of food systems. And you can either agree or disagree with that. And I think you're all very efficient at voting, so it should happen nice and quickly. You need to be logged on at slido.com with www.ae. It looks as though, yes, people are now voting.
Unanimous consent.
Yes, this is, and that actually is in fact a very good statement upon which to finish this session. The recording will be made available with a blog in due course, and we will continue to use social media to take this agenda forward. Combining land and water is fundamental to food system transformation, and the revision of the agroecological principles that have been presented today, and the examples that we've seen of them being put into practice around the world, is testament to the importance of water and aquatic foods in agroecological transformations. Thank you, everybody, and we look forward to taking this agenda forward with you in due course. And with that, we close the session on time.